Okay, this particular YouTube video is for anybody that's having the requirement of figuring out what the prime and composite numbers are for the first 100 numbers. This is usually around 4th or 5th grade that it's required. And it might show up on a achievement test for your particular state. And it's usually only between the numbers 1 and 101, because I want to include 100, just in case you don't realize that that's a composite. And so beyond that, that's usually the higher grades that you would need to understand that. But before we get to doing this this method of having basically a number chart of 1 to 100, of course you can print one out, teachers, and have that for your students. But as far as the kids themselves, when you take your achievement test, they often give you graph paper, or they might even give you a grid which has 100 squares in it. If this happens to you, students, then great, you can just fill it in, or you can just take simple college rule paper and make, because they'll hand you scratch paper for the test. Most of you, of course, will be doing some digital version of the test, but they'll give you scratch paper and you can just make a grid very quickly with 2 pieces of paper. Use one as a ruler and make 10 columns, 10 rows, and ta-da, you have 100. And with that 100 chart, you can go through as you learn the techniques, and we're going to talk about the different types of composites that we need to look for in the first 100 numbers. Obviously, prime numbers go on forever, but you do not have to know all that. In 4th, 5th grade, you just need to know the first 100. I teach down here in Virginia, and it's 5th grade that it's required to know the first 100, but that's pretty typical around that age area. That they need to know the prime and composite numbers, and it's pretty much across the board. Just the first 100 numbers do you need to be able to identify if they are or not. So let's talk about what a prime number is. Put this to the side for right now, and let's talk. Okay, so a prime number prime numbers only have 2 whole number factors that equal it, and so we're only referring to whole numbers, not 0. 0 is not a true whole number because it has no value. Therefore, it cannot be a prime number, nor can it be a composite number. 1 is a true whole number, but it is also neither a prime nor a composite. A prime needs exactly 2 factors only. A composite needs 3 or more different factors. So again, 0 equals nothing. Obviously it's not just one set of factors for this one. It can go on for infinitum, 0 times whatever. But the point being is it's not a real value. And you might be thinking, well, I know that 1 times 1 is not the only thing that equals 1, because I could do 2 times 0.5. True, but then 0.5 is a decimal and is obviously not a whole number. And so when we say prime and composite numbers, we're referring to whole numbers. Also, when you refer to odd and even numbers, you're actually referring to whole numbers. And that's so we're not dealing with the decimal. Okay, so having said that, now let's talk more specifically what would fit under the category of a prime number. So as we said before, a prime is a type of whole number. A prime number has only 2 different whole number factors, examples and non-examples. So 1, we know 1 times 1. There's no other whole numbers that equal that. So obviously I have it scratched out because this is definitely a non-example, not a prime, not a composite, because it only has 1 factor. And remember, composites have at least 3 factors or more. And so it can't be a prime, which must have 2 different factors only, and it can't be a composite because it has to have 3 or more. 2 times 1, okay, well, there's 2 different factors. Is there anything else that would equal 2? Well, obviously, there's 4 times 0.5, but again, that's a decimal. And so as far as whole numbers, the only thing that multiply together to equal 2 is itself times 1. And so those are the only 2 different factors. So it is a prime. It is a prime number. Same thing with 3. Only 3 times 1 can equal that. Again, you could do 2 times 1.5 would equal that, or 1 and 5/10, but that would be a decimal, and decimals are not whole numbers. So only these 2 whole numbers times each other equal 3. Therefore, it is a prime. But once you hit 4, you know that 4 is a multiple of 2, and anything that's a multiple of another number, even if that number is a prime number, well, it cannot be a prime because it has 3 different factors. Now, it obviously has 4 factors, just like 1 has obviously 2 factors. So you'd think, oh, that should be a prime. But these 2 are not different. That's how we distinguish a prime. And so here we have only 3 different factors, but it's 3 or more makes it a composite. So, it has 4 times 1 equals 4 and 2 times 2. So that's 3 different factors that equal that can equal this by either multiplying to themselves or multiplying to themselves. All right, so 5 times 1, and it just goes on. And then the same thing, 6 is a multiple of 3, 6 is a multiple of 2. So clearly that so it has 4 different factors. So it's not a prime, it's a composite. 7 times 1, again, we're back to where we were before. 3.5 times 2 could equal it, but that would be decimal, and that's not whole numbers. So only 2 whole numbers can equal 7. 7 or 1 times itself. That's it. So that makes it a prime. The 8 has several, okay? And 9 has 3. So those are examples of composites. 10 has 3 or 4, sorry. So it's a composite. Then we go back to 11. It's only 2 again. So it will just go on and on as far as there being primes and composites. And there is a technique in order for you to find those, and we'll get to that in a second. Let's finish talking about our. Let's talk now about now that we've discussed that. Let's talk about composite numbers. So composite numbers. Composites have more than 2 factors is usually the typical thing that you hear. I don't like saying that, but that's unfortunately the most popular way of identifying what a composite is. You say the words has more than 2 factors. But often all you hear, kids, is, oh, 2 factors. Oh, okay. All right. Oh, this number 2 over here has 2 factors. It must be a composite because it has 2 factors. No, it's more than 2 factors. So I like to throw around the words 3 or more. 3 or more. So if you're going to learn it, even though you're going to hear it the other way, please think 3 or more different factors, not more than 2. And you just see that 2 and then you're like lost. Okay, so please 3 or more different factors. Or when speaking in terms of division, referring to composites, have 3 or more different whole numbers they can divide with. So again, like we know, 2 is not one of those because it only has 2 exact factors that equal it. 3, the same thing. So these are primes. So remember, composite is a direct opposite to a prime number. It has not 2, but 3 or more different factors that equal it. So like we talked about 4 already, and that's why it's a composite. So I just wanted to make sure that we had that knowledge in place before we moved on. So back to the number chart. So we have this number chart here, and in this number chart, when we construct this number chart, let's say we're doing a test, we're doing the achievement test at the end of the year, and this video is posting around the end of the year, so a lot of you are taking your math test pretty soon, and all you have to do is write out a number chart, and 1 to 100. I would recommend that you do 10 rows, 10 columns, and then just put them in, first 10 first, next 10, next 10, and just keep going. And then you can obviously 0 is not mentioned, so that's not a big worry at all. But 0, of course, is neither a prime nor a composite because it's not a whole number. It has no value. Just like a decimal is less than 1. Same thing, 0 is nada. It's like saying black is a color. Well, we know it's not. It's the opposite of it. Because color is reflection. Black is when the light is fully absorbed. So it's 0 is basically the black of the number world. It is not a color. It is not a value. Black's not a color. 0 is not a whole number. Okay, so we have 1, which we can automatically eliminate. So we're going to put an X by it because it's neither. And it's the only one in this number chart that's going to have this issue. So we're going to block that. We're going to X that out right now. Because it is neither a prime nor a composite. It doesn't have 2 factors exactly. So 2 different factors. 1 times 1 is only 1 distinct factor. So it is not a prime, and it's not more than that. It's not more than 2, obviously, so it's not a composite, so we don't circle it either. Okay, so now we go to the list of numbers, and here, let me see, I had a really cool list to refer to. Let's see if I can find it. Yes, so here it is. This is just a pattern that I remember, that there were 4 in the first 10 numbers that are prime. But most importantly, just look at these set of numbers. These are, in fact, the only numbers that you need to know are prime. So that would mean everything in that number chart I just showed you, except for the number 1, are composites, if they're not these numbers. So these are the only primes. So I'm going to be continuing talking for the next 5 or 6 minutes. And it's going to take a little bit of practice for you to just be like, oh, okay, I get it now. Now I know them. Or if you're good at remembering and just cramming this knowledge in your mind, you could totally store this in your memory and then do a brain dump. Just when you do the achievement test and the teacher reads the directions, hands out the scratch paper and says you can begin, you can just pour out and write these numbers out. You could even write them out like this, where you know that there's 4, like I had right here, 4. I had a couple little tricks that I was thinking of, 44, 22, 32, and then the mirror opposite to it, 23, 21. 44, 22, 32, 23, 21, and just remember, oh, okay, and then you write them out like this, and then be like, okay, I need 4 for the 1 through 10 that are primes, and then kind of try to recall those, and then go and then be thinking, what are the next ones? Another trick that you can learn is look at a times tables up to about 47, and when you look at the times tables and compare it to the number chart, you can be like, what numbers, just counting 11 to 47, not the top ones, and then because you should know these are key that you know these, and be like, oh, okay, these 4 are the first primes. But the other ones, you could just be like, oh, I'm going to look at the number chart, and everything up to the 40s, in the 40s, all the way before you get to 50, or that if it's not in the number chart, if it's not in the times table chart, and you can make your own times tables for the test, that's easy. If it's not in the times tables chart, then it's not. If it's not in the times tables chart, then it's not a composite. It's a prime. And so that would be an easy way to get these numbers But then it's not so easy here because you have numbers like 51 that don't show up in the times table chart, but 51 is a composite of 3, and we'll talk about that. 69 is a composite of 3. 39 is a composite of 3. So I take that back on the 30s. You could probably only take it up to the first two. But, 39 you can almost tell, because 3 goes into 39. And you'd be like, oh. And then there's 42 and 45 and 48. But those are also multiples of other numbers. So that's why you would know that those are not prime numbers. But so I think 39 would be the only one of the early numbers that you'll mess you up. But 51 tends to be the one that shows up on an achievement test. They or a unit test. They really want to mess you up on 51 because people don't make that so obvious. 69 a little bit, but like 69, like 39, you can look at 69 and be like, oh, well, I could see 3 goes into 69. So just memorizing this can avoid that whole conversation we just had. You could just be like, oh, okay, I just memorized this dude, and I can turn off this video right now. But if you're one of those people that needs a method to understand, then you need to keep running this video. So let's keep going. All right. So now that we've done this, let's talk about finding finding these composites. Okay. So as we said before, the first 4 prime numbers are key to identifying composite numbers if you want to use a method instead of just memorizing the ones I just showed you. 2, 3, 5, and 7 are the only primes in the first 10 whole numbers. And with the exception of 0 and 2 only, all numbers that end with 0, 2, 4, 6, and 8 are composites and multiples of 2. So obviously we didn't mention 2 here because 2 is a prime. And 2 times 1 are the only 2 factors, different factors that equal 2. But after that, you have 4, 6, 8, and notice now, I did say 0, but I was saying because 0 is not a multiple of 2, okay? And 2 is technically a multiple of 2. It's the first multiple, quote unquote, but is it really a multiple of 2? No, it's the base. And then this would be the first multiple, but that's not how we call it. We call this the second multiple. It's the second number in the list of multiples. You start with 2, then you go with 4, but 2 is a prime number and therefore it doesn't count as, So when we're talking about true multiples, that means, you have 2 of them. You have 2 sets of them at least. A set of the original one plus another one of the same pattern. Then plus 2 again, so then that's 4. Then you have 2 times 2, and you have the distinction, and you also have 1 times 4 equals 4. So that's the 3 different factors that we need that makes it a composite. So these are all composites. So we identify the composites that way. And any number that ends on a digit that's 0, 2, 4, 6, 8, 0 again is going to be an even number, yes, but also a multiple of 2, and obviously therefore if it's a multiple of 2, it's a composite. Okay, now let's move on to the next one that you should definitely know. But actually, let's pause here for a second. Let's eliminate these 2's. Okay, so we go over here, and very quickly, I even give you a moment on the video because we'll probably put this on, or you can put. I definitely recommend that you use something like Edpuzzle to present this, teachers, and then you can just have it pause and you can throw in questions about each row. But I'm going to pause it anyway, or rather give you a moment to think what would be the prime numbers for this one. And well, this is easy because we already have them right there. So prime numbers, here we go. So we have 2, 3, 5, and 7. And it's now with this knowledge that we learned about let's circle all of the composites of the 2s. We're not going to worry about the 3s because we know this is a composite of 3s, 3 times 3, but we're not going to address the 3s for a while. In fact, that would be the last one you want to address because 2s are so easy, because anything that ends in 0, 2, 4, 6, or 8 is an even number. So wow, we can just go to town on the 2s, like really fast. So here we go. 4, 6, 8. Look at this. Ends in 0. So therefore, unlike 0, it is a real whole number. And it ends in 0. It's 8 plus 2. It's a multiple of 2. Therefore, it's a composite. Okay? 12 ends in 2. Doesn't matter that it has a 1 in there. And so if you're thinking about even numbers and odd numbers, remember it's the last digit that matters. And the last digit in even and odd numbers, this is an even digit. Okay? That's what matters. It determines that this is an even number. It's also ends in 2, therefore it is a composite of 2. Okay. 14, 16, 18, 20, 22. And so as you can see, all these even numbers are already set up for us, so we can just go straight down at this point. 32, 42, 52, 62, 72, 82. And this doesn't take a long time. And there will be, at least I know for Virginia, there's probably going to be at least 4 questions that are going to be private composite. And that's 4 questions you could easily get right. And remember, nowadays, achievement tests aren't like how they used to be. Back when I was a student, it was, you had a specific time limit. Now you have the whole school day to complete your achievement test. And so you have plenty of time to do it. And this, the chart doesn't take very long at all, a minute or two. And then doing this whole process could take you 10, 15 minutes. But that will guarantee that you get those 4 questions right. And those are often the area that shows up as a weakness for a lot of students. Okay, is not understanding or not being able to identify these primes and composites. So we just get care of all of these even numbers. And, as I have done this, you can easily have, like when we were at that first part of the video, you could ask a question, be like, okay, now guys, go and identify all the ones that end in 0, 2, 4, 6, and 8 and circle them. And then after they've done it, watch the rest of the video and be like, oh, I missed this one. Oh, I forgot that one. Oh, I didn't think about going straight down. I could have done that. And so then they're going to be able to remember that technique next time and be like, oh, wow, I got all these numbers out of my way, and I don't have to worry about these. Like I said before, the one that's going to be the biggest challenge is the 3s. But there's a couple easy techniques. One of those involves division, and you'll be able to find it rather quickly. You just need to remember it. And so this is a process that takes altogether maybe 15 minutes, kids, to find it all, to write it out and do it all. Or you find this too much of a task, you could just easily memorize those numbers that I showed you. It's not that many. I think it's less than 30 numbers. I think it's a lot smaller than that. A lot less than that. So then you just keep going. Okay, so now let's talk about fives. And we've actually taken care of half of the multiples of 5 already. I'm going to explain why. So with multiples of 5, with exception of the number 5 and 0, all numbers that end with 5 or 0 are composites and multiples of 5. You have 10. The 0 is what we're looking at, though. Notice the whole thing is not underlined. We're just focusing on the zeros. It's a multiple of 10. Multiple of 5, because it would be 5. 5 doesn't count because it's a prime number. And then comma, the next multiple, the second multiple, quote unquote, when in actuality it's the first. But anyway, second multiple of 5 is 10. And that 0 right there, 5 times 2, 10. 5 times 3, 15, 20. But we've already circled all of the multiples of 2 that equal 10, or one of the 10s here, 10, 20, 30, 40, 50. But so we got half of the 5s out of the way. Now we just all the ones that end in 5. Don't count 5 though. But see, after this point, you have them all right here in one single column. Nowhere else, just here. So then you just circle all of these. Look at that. You've just eliminated a half of all of the composites that you need to identify. And this will help you to identify the primes, because you got half of them out of the way already. Boom. 7 is pretty simple as well. So let's talk about 7 very quickly. Okay, so now we have the 7s. 7s, pretty awesome here. Multiples of 7. Define composites or multiples of 7. I would refer to a times table or the first 12 math fact answers of 7, and then add 7 2 more times. The only one that is not a composite, of course, is the 7. So 7 is a prime, so we don't count that. It knows all these other ones. So when you look at a times tables, you'll have 7, 15, 21, 28, 35, 42, 49, 56, 63, 70, 77, and it will go to 84. So all I have to do is add 7 more. In other words, 7 times 13, 91. Then another 7, and you got 98. Obviously, 98 is not a slippery one to worry about because it ends 8, so you already know it's a multiple of 2, and so therefore it's already been eliminated. We already took care of that multiple of 7, but 91 is very sneaky, and so we would automatically almost look at it and be like, oh yeah, that's definitely just a prime number. And then so 91 is one of those tricky ones. 91 is a composite. 1 is a composite as well, and so those two are slippery. Okay, and so how would I even know that those are? Is remember the facts, or remember the multiples of 7, and then go 2 more. When you're doing an achievement test, I recommend you actually write out a times tables, because kids, if you're one of those students that struggles at times tables, which is very common nowadays, if you struggle with it, one thing that you're really good at, the one thing all students are good at, is adding and counting on your fingers, and you can add up. So if you can just get into the practice of having those 2 columns of the same number on the left side, the 2 rows on the top, and then have the little times X at the top, and then just fill in the chart and do all the way to the 12s, and go from the 1s to the 12s, and do all of that all the way to 144. You get that whole thing written out. Then you can just look at it, and then boom, and that might take you an additional 5 to 10 minutes, but that is something that's going to help you throughout the entire one section of the achievement test. Half of your achievement test is going to be a non-calculator, and then you're going to have that times table that's going to help you with division. It's going to help you with the 7s for the prime. It can help you with so much. So it's very important, and I can't emphasize it enough. But let's say you did know just the multiples of 7 already, and or let's say you're a whiz at it, and you're like, I'm not doing times tables because I know all this stuff. You might want to visually have it written out anyway. So then you write it out, and then you add the 2 more to it, and then you're like, oh, okay. And then you can look, and you can just start eliminating these. So you go through, you go back, and you find out, oh, okay, the 14th multiple of 7 is already circled, but, oh, guess what? 91 was not circled, so that is a composite. And then you go through and you find, and unfortunately you can't just look at the end and say, oh, that ends in 7, because we know that neither one of these times 7 equal these numbers, or 7 times anything equals these numbers, so that doesn't help you. So you just have to know your multiples of 7 and say, oh, there's the 14. Oh, here's the 21. It's also a multiple of 3. Got it taken care of already right now. Boom. Next one, 28, already taken care of. Next one, 35, already taken care of. Next one, 42, 7 times 6, already taken care of. But here's one, 42 plus 7, 7 times 7, 49, not taken care of. Next one, 56, 7 times 8 is 56, taken care of. Then 7 times 63, not taken care of. But you can also look at it and be like, oh, 3 can go into both of these evenly. 3 goes in there 2 times, and then 3 goes in there once. So boom, you already know that for that. Okay, the next one would be 7, so then that would be 70, already taken care of. 70 is 70 plus 7, or 7 times 11. 77, awesome. And then the next one is the 12, which is 84. 12 times 7 is 84, and that's already taken care of. And then we'd have 91 and 98. So now see, so these things are so easy flow, because anything ending on a multiple of 2, the basic 2, 0 through the 0 through 0, 2, 4, 6, 8 is an even number. Take care of those. Anything ending in 5s, because you already took care of the zeros for the 5s, just anything that's ending in 5s, so just find that one row, the prime right there, and then circle those, and you have it done. And then you just do the 7s, write out the 7s like so, and then just find the 7. See, this, it could take a lot less than 15 minutes as you get in this habit. If this is one of your really challenging areas, you can do a number chart a few times, and that could be like your math fact practice. You might be already good at memorizing your math facts, but now you can just, make a few pieces of a number chart, even have it pre-written, and just circle. And there's no rule here that you have to circle them. I just chose circles, and I chose triangles for primes, and we're going to find more primes. But before we can find all of the primes, let's eliminate all the things that are 3 related. So let's talk about the last one. So 3 is the one that puts a lot more effort, and it often requires that you divide. There is, however, a trick that works. And of course, if you don't trust it, you can always divide it by 3, do your long division, and you'll find that 3 will get into it evenly. Or you could lean on this trick. So to find composites or multiples of 3, refer to a times table or the first 12 math fact answers, and then after that, just add the digits of the numbers that are larger than the first 12 fact answers and have not been identified yet as composites of 2, 5, or 7. So you're first going to look for your 2s, your 5s, and your 7s, get those out of the way, and then everything else we're going to tackle using adding the digits together. So when you add the digits and get one of the first 12 facts answers of 3, then you know it's a multiple or composite of 3. Okay, so the number 3 itself is the one exception. All other numbers whose digits added up to 3 or any of its other 11 original math fact answers are multiples of 3. So again, we said 3 is a prime number. It's only 3 times 1 are the only whole numbers that can equal 3. But everything else is, more factors. 6 is, 3 times 2, and 6 times 1. There's 3. There's definitely 4 factors there. So, so we know that is a composite. But once you get past 36, then what do? Well, this is where we add. So you take 39 and you, add this digit plus that digit, and it equals 12. And 12 is the fourth multiple of 3. Or you could, if you don't trust me, take 39 divided by 3, and it goes in there one time. 3 goes into 3 one time. And then do the subtraction underneath. 1 times 3, 3. And so 3 minus 3 is 0. Bring down the 9. 3 goes into 9 3 times, so that's 13. 13 times 3 equals that. Now, 13 is not the fourth multiple of 3, but 12 is. So if you add the numbers together and it equals that, it will always do that. It will always do that. In fact, if I were to just take, let's say, if I were to take a larger number, and you could go infinitum on this. So if I take the number, and we're past 101, but if you take 102 and you add 1 plus 0, that's 1, and then plus 2, that's 3. You add these together, and then that is a composite of 3. And if you didn't trust me on that, and you don't believe me, just do a really quick, sorry, that should be a 2. Just do a quick little division, and you're like, oh, okay. 3 goes into 10 3 times. 9, subtract 12. 3 times what? 3 times 4 equals 12. No remainder, 34. So 3 times 34 equals 102. And this will work every time. So if you can add the digits up, you could have a Google of numbers listed. You could have, starting from the Google place, ones place value, you could have 3, 3, 3, 3, 3, 3, 3. Add it, it's going to make a very large number. But if you kept, then you add those together and make it a smaller number, add those together and make a smaller number, add those together and make a smaller number, and eventually you'll get it to, it will be one of the math facts between 3 and 36. And so then we know, oh, it is, in fact, a multiple of 3. Or you could actually do a division on a Google. But that would take a very long time to divide. I don't recommend it. So, that's how easy it is. That is that is the final one that we need to do. So we could just tackle that right now. So here we go. So let's try it. So now we have all these numbers left over. Is 9 a multiple of 3? Yes, of course. It is third multiple. So we already know that. We already know our times tables. If we didn't, we would refer to it. We'd create our own times tables out, guys. Take us maybe 20 minutes of the achievement test to create the number chart, to create the times table chart, and then boom. Well, the number chart won't take you that long. But anyway, but through these different processes, only 20 minutes of your time. And many people will finish the achievement test in 45 minutes. They score very poorly. Even the best students take at least an hour, hour and a half. They're not going to finish in a half hour. That's a red flag that you totally don't know what you're doing. Okay, so take your time, do it right, and then boom, you know that this is enough. So if you're like, oh, I'm just nervous, then refer to your times tables. So you might be like, yeah, I know this stuff. I got it. Don't. You're not impressing anybody. Just take your time and do well. Okay, so then let's go to the next one. 11. 1 plus 1 is 2. Is 2 a multiple of 3? No. Since we've already eliminated all the other ones, guess what? These are all primes. So if it's not a composite of 3, then they are primes. So if these two digits together do not make a multiple of 3, which is between 3 and 36, then it is a prime. So we don't even have to worry that what if it lands on 39? Not going to happen. And if it did land on 39, it won't happen in the first 100, but if it did land on 39 after adding the two digits together and you got 39, well, you just add the 3 and 9 together and that's 12. And so that's what you would do when you get large numbers like Google something, then you could just add them and add them and add them until finally it's going to narrow it down to these, and then you'd be able to see. And if it doesn't and it equals 37, then you're like, oh, or I'm sorry, 35 or whatever, then you know it's not. And remember, these techniques of adding the digits together doesn't help you to find fives, doesn't help you to find multiples of 2 or multiples of 7. It only works for the threes. Okay, so going back. So then again, this is only 2. I'm sorry. So this is not a composite. I apologize. So this is a prime. Okay, so that's a triangle. And then again, 1 plus 3 is 4, not 1, so that's a triangle. We found another prime. Okay, 1 plus 7 is 8. 8 is not a multiple of 3. We found another prime. You know, another thing to remember is, especially if you're doing a digital achievement test, they're going to allow you to have a digital highlighter, and you can, well, I'm sorry, that's not going to be helpful. But anyway, I was just suggesting and marking things with highlighters, but you're not going to have a number chart on the screen, per se. So then you have the next one. But then again, maybe they allow highlighters in different settings of achievement. So maybe that is an option for, you know, since if there is highlighters on the digital version, maybe the teachers will allow highlighters. So I don't know. That'd be something to ask. Okay, so then 1 plus 9 is 10, and so that doesn't equal. 1 plus 7 is 8. 2 plus 3 is 5, and 5 is not a multiple of 3. And you know, it doesn't have to show the number anymore. We can totally just, but you know, let's leave it. What about this one? 2 plus 7 is 9. Oh, 27. You already know. This is one of the basic math facts of, so you don't even have to, you just be like, oh, circle it. You know, this is, you know what's what for this one. You know what's what for this one. And you got all the basic multiples of 3. And then this one, 2 plus 9 is 11. Oh, we found a prime. But anyway, I'm doing it quickly, and you know, because of this video, but you can definitely do it a lot slower than this. And me explaining is what's taking all the time. So this would not, even though I'm doing a long, lengthy video, this is for your practice. And then you can be like, oh, so you watch this, you absorb this, and then just practice it. Practice the things that I talked about in the notes. Write down the notes. Go back, write down this information. Fast forward, go to the spots that help you. Okay, so like I said, so 3 plus 1, that's 4, that doesn't work. 3 plus 7, that's 10, that's not a multiple of 3. If you get bored of this order, you can just go straight down and do it too. 3 plus 9 is 12. Is that a multiple of 3? If I don't remember, I go back to my times table chart, or I can list out my 3s to 36 and then be like, well, did that equal one of these? Yes, it equaled 12. So guess what? This is a composite of 3. You don't believe me? Divide it by 3. 3 goes into 3 one time. Okay, and then 3 minus, and then so 1 times 3 is 3. So 3 minus 3 is 0. Bring down the 9. 3 times what equals 9? 3 does. So that's 13. So 3 times 13 equals 39. So that's a composite. You don't need to distinguish that it's a composite of 3. You just need to distinguish that it's a composite. So when they list a list of numbers, they're going to throw in primes. They're going to throw composites, and they're going to ask questions like this. You know, which one of these lists is only composites? Which one of these lists is only primes? And with these techniques, you'll be able to do it. Or you could just memorize the, I don't know, less than 30 numbers that I showed you. It was a lot less than 30 numbers. And you can just totally have that memorized, and that would be maybe even easier than this. But it wouldn't help you to understand the concept of identifying composites and primes beyond that. Because even though 5th grade only requires that, when you get college, you need to know how to identify a prime and how to identify a composite in the hundreds, in the thousands, in the millions, in the billions, in the trillions. Okay? So, again, 41. 4 plus 1 is 5. That's not a multiple of 3. Oh, sorry. So, again, like I said, it would be nice if you had like a highlighter, then you could identify certain things a certain way, highlight ones. Maybe you circle composites and you highlight primes or something like that. That might be even more helpful if it was allowed, colored pencils or a highlighter during the achievement test that you took, if something like that was available or possible. Don't know. So it depends on the region. So 4 plus 3 is 7, not a multiple of 3. So again, you do the triangle. And if you go slowly, you won't make the simple mistake like I'm making where I accidentally circled it. Okay? And again, 4 plus 7 is 11. So that doesn't work. So 4 plus 7 is definitely not. Okay? So that's a prime. Now, you might make a mistake of thinking everything down here, but look at 27. 27 was a composite. So add these two. 5 plus 7 is 12. Up, multiple of 3, because that's there. So that is a circled one. And you're going to focus on the triangles for the primes. And then all the circles ones are composites. Take your time. 6 plus 7 is 13. Okay? Well, we tried the 2s, we tried the 4, tried the 2s, the 5s, and the 7s wasn't one of those. And it's definitely not a multiple of 3. So guess what it is? It's a prime. Okay. 8 plus 7, 15. Multiple of 3. Circle it. 9 plus 7 is 16. Not a multiple of 3. So guess what? This is a prime. 5 plus 9 is 14. So that is not a multiple of 3. It's a prime. 6 plus 9 is 15. That is a multiple of 3. So we circle it. 7 plus 9 is 16. That's a prime. It's not a multiple of 3. 8 plus 9 is 17. It's a prime. Not a multiple of 3. 9 plus 9 is 18. That is a multiple of 3. So we circle it. And guys, we just did all of them. Well, no, we didn't. We forgot these over here because of the way we did it. 5 plus 3. That is a prime. 7 plus 3, prime. 8 plus 3, prime. 9 plus 3 is 12. So it's a composite. 81. That's 9, multiple of 3. So 9 times 9, right? 7 plus 1 is 8. I'm sorry, this is a composite because it's a multiple of 9 and multiple of 3. 8 plus 1 is 9 and it's multiple of 3. This is a prime because that's 8. 6 plus 1 is 7, prime. But 51 is 6, so that's a composite. Now you have all of them. Okay? Whew. That's a lot. But it doesn't take that long. So good luck, and I know you'll do fine.